Incineration, or energy from waste, provides an effective way of diverting large amounts of waste from landfill while recovering useful energy. This incinerator plant generates electricity by burning 90,000 tonnes a year of non-recyclable municipal waste collected from within the county. It was commissioned in 2003 and is one of a number of incinerators that collectively play a key role in achieving the county's challenging recycling and recovery targets. It's a comparatively small plant that meets the operating and pollution control standards set by the national regulator under IPPC, and it complies fully with the Incineration Directive of 2000. The site is a couple of miles outside the town centre and was the location of an incinerator that was closed in the 1990s when the first Incineration Directive was implemented. There are two main buildings, one for the waste delivery and storage and for the furnace itself. The other houses the flue gas cleaning equipment. A third smaller building houses a steam turbine and the associated power generating equipment. The incinerator is fed with household waste, and all vehicles entering and leaving the site are weighed. The vehicles discharge their load into a bunker which holds about 4 days' supply. A grab crane distributes the waste throughout the bunker and mixes the incoming loads to give a consistent feed quality. Mixing's important because too much of one type of waste affects the burn rate and consequently the heat produced. The crane also lifts the waste into a hopper at the top of the furnace feed chute. The rubbish falls down the chute under its own weight, and it's then pushed into the furnace by means of a ram. Combustion occurs as a modern version of the conventional reciprocating grate furnace. Primary combustion air is supplied through the grate, and a proportion of the cleaned flue gas is re-injected into the furnace. This reduces the formation of oxides of nitrogen. The need for secondary air injection is removed, as the re-injected exhaust gases create the turbulence in the furnace that's necessary to ensure complete combustion. A further reduction in oxides of nitrogen is achieved by injecting urea into the furnace. On leaving the furnace, the gases are cleaned in a semi-dry scrubber. Lime slurry and activated carbon are sprayed into the large reactor through which the gas flows. The heat from the gas evaporates the water from the slurry, leaving fine lime particles that neutralise the hydrogen chloride and sulfur dioxide. The carbon adsorbs mercury vapour, dioxins and other trace organic compounds. The gas then flows into the bag filters where the solids, known as air pollution control ash, are removed. The APC ash is conveyed pneumatically to a storage silo and later taken by tanker for disposal at a hazardous waste landfill. Meanwhile, the cleaned flue gases are discharged through a 65-metre-high chimney. Systems continually monitor the concentration of key pollutants in the flue gas. If concentration levels rise, the plant operators are informed so that they can take action. The emission measurements are published on the company's website, and if discharge limits are exceeded, the national regulator is informed. A second and different type of ash is the residual ash from the furnace. It's often called bottom ash, and it drops off the end of the grate into a water quench bath to cool it and to reduce dust levels. It then passes under a magnetic separator. Any recovered ferrous metal can then be recycled. Most of the bottom ash is sent to an industrial waste landfill, but increasingly it'll be processed with the ash from the county's other incinerators and used as an aggregate substitute for road building projects. Treated feed water is converted to steam in boiler tubes that line the furnace walls. The steam is then superheated by passing it through a second set of boiler tubes located at the top of the furnace chamber. An economiser is used to preheat the boiler feed water. This increases the efficiency of the heat recovery system and reduces the gas temperature, thereby raising the efficiency of the gas cleaning system. On leaving the turbine, the steam is condensed back to water in the condensers. The facility may be run as a combined heat and power plant, which would increase the efficiency of the energy recovery process. However, at present there is no local demand from industry or from housing developments for steam. And finally, of the 8 megawatts produced, about 1 megawatt is used to run the plant. The remainder is supplied to the national grid.